We will discuss different types of Ksp problems in this video. There are 4 types of questions we can expect in Ksp problems. So the first one is given molar solubility, find Ksp, and vice versa. That is given Ksp, find molar solubility. And third type is given Ksp, find molar solubility in presence of a common ion. And the last type will a precipitate form when two solutions are mixed. So let's go ahead and see the first type, which is the molar solubility of silver sulfate is 1.5 times 10 to the power negative moles per liter. Calculate the solubility product of the salt. So here we have to calculate the solubility product. So that means we have to calculate the Ksp. So we should know how to write the Ksp expression for this salt. The salt here is silver sulfate, correct? So first let us write the formula for silver sulfate, which is Ag2SO4 solid, and it will dissociate into silver ions, that is Ag plus S and sulfate ions, which is SO4 2 minus, that is AQ here, and to balance we have to put a 2s coefficient, correct? And then we should know how to write the Ksp expression. We know products over reactants. We don't need the reactants because it is solid. So we will just write the products. So we can write Ag plus, and we have a coefficient of 2, so to the power 2, and SO4 2 minus. That is our expression. So also we know we have 3 ions here, 2 ions of Ag and 1 ion of sulfate. So we can write Ksp equal 4x cubed. That means it will be 2x to the power 2 and x. So that's how we are getting 4x cubed. And what is given is the molar solubility. So molar solubility is x. X represents the molar solubility. Sometimes the variable is represented by the letter S as well, but I am using x. Okay. So how can we calculate this one is 4 times. We are just substituting the given molar solubility, which is 1.5 times 10 to the power negative 2 to the power 3. So that equals 4 times 3.375 times 10 to the power negative 6, which equal 13.5 times 10 to the power negative 6, 1.35 times 10 to the power negative 5. So to match with our significant figure given in the question, what we will do is 1.4 times 10 to the power negative 5. That is our Ksp. So this is method 1 by directly substituting in that Ksp equal 4x cube form. And another type is by using Rice table. So in that case, what we will do is we will first write the equation, and then we will write the initial concentration. Initial concentration of silver ion is 0, and initial concentration of sulfate ion is also 0. And the change is for the reactant, it is negative x. The normal Rice table we are writing, and this is plus 2x, and this is x. There is a 2 here, so it is plus 2x. All right, so now x is 1.5 times 10 to the power negative 2. So the plus 2x, that is 2x, will change to 3 times 10 to the power negative 2. And then we can substitute in the Ksp expression. So that means silver ion is 3 times 10 to the power negative 2, and sulfate ion is 1.5 times 10 to the power negative 2. So then you will get the same answer. So either you can use the Rice table like this, or you can substitute in the other form. Okay. And now let us see. Copper 1 bromide has a measured molar solubility of 2 times 10 to the power negative 4. That means molar solubility X is given, which is 2.0 times 10 to the power negative 4 moles per liter. And then calculate the Ksp. Same type of question. How are we going to calculate Ksp is, first we will write the equation, that is copper 1 bromide. So CuBr solid will give us Cu plus Br minus. So 2 ions. So we can actually just substitute in the form Ksp equal x square. So x is 2 times 10 to the power negative 4 to the power 2. And you will get the answer 4 times 10 to the power negative 8. So if you are writing in the rise table, you can go through the rise table and you will get the same formula, and that is Ksp equal x square form you will get, and then you can substitute. Okay. And now let us see one more example. In that example, what I want you to do is just go ahead and try this question by yourself and check your answer. You can pause the video and check the answer. Okay, so you should have an answer that looks like this. So in this case, we are going to get how many ions is 5 ions, correct? So we will have 2 Bi, 3 plus ions and 3 S2 minus ions. And then we will get the formula 108 times x to the power 5. So then you just substitute the x value given in this question, which is 1.0 times 10 to the power negative 15 to the power 5, and you should get the answer 1.1 times 10 to the power negative 73. And now let us see the type 2 calculations. Calculate the molar solubility. So that means here we have to go ahead and calculate x. Calculate the molar solubility. What is given here is Ksp value of calcium phosphate is given. So first what we will do is we can write the rise table, and we can write the initial concentration and then change. So Ksp expression we can write with this one. At equilibrium we have 3x for calcium and calcium ion, and we have 2x for phosphate ion. So when you write the Ksp expression, we can write that Ca2 plus to the power 3 because coefficient 3 here, and PO4 3 minus to the power 2. And then what we will do, we will just substitute the Ksp value and we will find the X value, that is our molar solubility. Okay, so either you can go this way or you can go directly by putting, since there are 5 ions, we can write Ksp equal 108 x to the power 5. That means you are actually skipping the rise table and then you are directly writing that one. But it is always your choice. Either you can go with that rise table or you can go with this one if you are thorough with that. Okay. So if you are using the rise table, less chance of making error, but this one you may have to be very thorough with that to apply this formula. Okay, and then Ksp is 108 x to the power 5. What I will do, I will substitute the Ksp value, which is 1.2 times 10 to the power negative 26, and this is going to be 108 x to the power 5. You can plug it in the calculator, which is x equals 2.6 times 10 to the power negative 6 molar. Okay, so that's how you can do this type of calculation, that is type 2. So now let us try one more question. The Ksp value for copper 2 iodate is 1.4 times 10 to the power negative 7. So Ksp value is given, and they are asking us to calculate its solubility. That means X. We have to calculate X, and they have given Ksp. Alright, so either you can use the rise method or you can use direct substitution. So first you should know how many ions it's going to form. So we can write the equation, and let us go ahead and write the ions here. We have copper 2 plus ions, and we will have 2iO3 negative 1. Okay, so we have 3 ions here. So 3 ions means we will have 4x cubed. Ksp equal 4x cubed. And then I'm going to substitute 1.4 times 10 to the power negative 7, that equal 4x cubed. And then we can find x cubed equal 1.4 times 10 to the power negative 7 and divided by 4. Okay, so then we will have 0.35. I simplified that one. That answer 3.3 times 10 to the power negative 3. let us see the third type, that is in presence of a common ion, how are we going to do the calculation? Okay, so in this case, the solutions, so a solution is mixed. So we can see that lead 2 iodide is mixed with the sodium iodide. So what is the molar solubility of lead 2 iodide in a 0.05 molar solution of sodium iodide? So in this mixture, we have PbI2 and we have NaI. So we can see that PbI2 will give us Pb2 plus and I negative ion, and sodium iodide will give Na plus and I minus ions. So we have a common ion present in that. So how is that going to affect our Ksp? Let us see that one, or the solubility. All right. So what we will do, first we will write the equation. That is PbI2 gives Pb2 plus 2 minus, or 2I minus, and then we will get our initial concentration. So that is the point you have to memorize in the common ion effect. So don't forget to put in the initial concentration of the common ion. So we have 0.05 initially from NaI, and then as usual change, and then equilibrium. At equilibrium we will have, for the I minus, we have initial concentration which is 0.05, and we have to add that to X. And what we will do now, we will write the Ksp expression, and then we will just substitute. So Ksp is given, which is 1.4 times 10 to the power negative 8, and X times, that is from the Pb2 plus, which is X, and then 2I minus, so we have to take the whole thing and put to the power 2 because we have a coefficient of 2 here. All right. And now what we will do is neglect 2x. We don't want that 2x because it is going to be very, very, very small. And then we will do x times, this is the x times 0.05 to the power 2. So when you simplify, you can get the value 5.6 times 10 to the power negative 6. So you can see that x value is 0.000056. How small it is, correct? So even if you multiply by 2, it is going to be very small. So when you add that one to 0.05, it is going to be very, very small value. So that's why even if we neglect that one, it's not going to affect your calculation. So the percentage rule, okay, so most of the questions we are trying to do now is it's all less than 5%. Okay, so we don't, but if the 2x value is given already, we have to consider. All right. If it is not given, we can just neglect. So the molar solubility of lead iodide in pure water is 1.5 times 10 to the power negative 3. So after adding NaF, that is, sorry, sodium iodide, NaI, what happened to the molar solubility? It changes to 5.6 times 10 to the power negative 6. It went down. You can see that. So by the addition of a common ion, the solubility will decrease. Okay, so decreased solubility of salt in presence of common ion. That is the important point you should remember. Let us try another question. You first try and you should get 6.4 times 10 to the power negative 8, and then you can check your answer. So you should get the answer 6.4 times 10 to the power negative 8, and please check your steps. All right. Okay. So let us try the fourth type. Will a precipitate form when two solutions mix? So here we can see two solutions are AgNO3, which is soluble, so AQ, and Na2CrO4, which is also soluble. And you are getting a precipitate. But are you going to get the precipitate always when you mix those two solutions in any combination? That's what we are going to figure it out. Okay. So, but you should know the basic rule, that is Ksp. If Ksp is greater than Qsp, no precipitate will form. And Ksp less than Qsp, precipitate forms. And Ksp equal Qsp means the system is at equilibrium. So what is that Q represent? We already know that is reaction quotient, which is the concentration not at equilibrium. Okay, not at equilibrium. So concentration, we are using concentration which is not at equilibrium. Whereas Ksp, the concentration we are using at equilibrium. That's the difference. Let's go ahead and see some examples. So here is the example. Two solutions mixed here are lead 2 nitrate and sodium bromide, and the solution is formed with a concentration of 0.015 PbNO3 twice and 0.0035 molar NaBr. Does a precipitate form? Ksp of PbBr2 is given. Alright, so what we have to do is first write a balanced chemical equation and identify the precipitate. And then we will write the QSP expression because the given concentration are not at equilibrium. And then we will just compare Ksp and QSP. So let's go ahead and try this question. So first we have to write what? The equation. So we will write lead 2 nitrate, so PbNO3 twice mixed with so NaBr, both are AQ forms, correct? And we are going to get the products PbBr2 plus NaNO3. So when you balance 2 and here we will get PbBr. So here we will get 2, correct? And then how are we going to write the Ksp expression? So here we know this is the solid and this is AQ. So we are getting the PbBr2 as the solid. So that is what we are going to look at it. So Br2 is the possible precipitate. So how are we going to write that one is Pb2 plus 2Br minus, correct? And then we can write the QSP Pb2 plus and Br minus to the power 2 because coefficient 2. And then what we will do, we have the concentration given from 0.015 molar PbNO3 twice means we will have from that PbNO3 twice, we will have 1 mole of Pb2 plus ions formed. So that's going to be the same concentration of that PbNO3 twice. Correct. And for NaBr, we have 0.0035 molar. That means we will have 1 mole of sodium ion and 1 mole of bromide ion form. So from 0.0035 molar, we will get 0.0035 Br minus ions. Okay. So here we have the molarity of Pb2 plus, and from here we are getting the molarity of Br minus ions. So we are going to just substitute that one and we will write the QSP. We will get the QSP. So the KSP is given as 4.67 times 10 to the power negative 6 and our QSP is 1.84 times 10 to the power negative 7. So that means KSP is bigger than QSP. So greater than QSP. So if KSP is greater than QSP, no precipitate forms. All right, that's how we are going to figure out. Let us see the same chemicals, same aqueous solutions mixed in a different concentration. So here we can see that lead 2 nitrate and NaBr mixed in this concentration. So what we will do, we will solve in the same method and we will see whether the QSP is greater than, equal to or less than KSP. So what we can do is we can do QSP equal concentration of Pb2 plus concentration of Br negative to the power 2 and then we will just substitute our concentrations given and we will have 0.0158 to the power 2. You know where is it coming from, correct? Okay, so we will have the answer 1.498 times 10 to the power negative 5 and that is our QSP and our KSP in the question given 4.67 times 10 to the power negative 6, and we have our QSP 1.498 times 10 to the power negative 5. So we can see that our KSP is less than QSP now. That means what? A precipitate will form. So in the previous case, we found that no precipitate formed with this concentration, and now we calculated that with this concentration and we saw that a precipitate forms. Okay, so that is the difference in the formation of precipitate when you change the concentration. All right, let's see another example. Exactly 2 milliliter of 0.04 molar barium chloride are added to exactly 600 milliliter of 0.08 molar K2SO4. Will a precipitate form? Okay, so the scenario is they are mixing two, that is 200 milliliter of 0.04 BaCl2, and we have 600 milliliters of 0.08 molar K2SO4. So we have to find whether the QSP is greater than or less than or equal to KSP. All right. So let's go ahead and see that. So first we have to figure it out which one is going to be the precipitate here. So we are mixing BaCl2 plus K2SO4. We are getting BaSO4 plus 2KCl. So the possible precipitate is barium sulfate. Okay, everything else is going to be soluble. So we have to take BaSO4 now to write our KSP expression, and we can write Ba2 plus SO4 2 minus. So KSP expression will be concentration of Ba2 plus concentration of SO4 2 minus. Correct? So we got that one. And now we should know what is the concentration of barium ion and what is the concentration of sulfate ion. So we can use our given data to find that one. So let's go ahead and see that. So here we have the volume, we have the molarity, we can find the number of moles. So I will change that volume into liters, so that will be 0.2 liters. And then when I multiply with the molarity, which is 0.04, I will get the number of moles, which is going to be 8 times 10 to the power negative 3 moles of barium ion. Okay, so I got the, let us calculate that one, as that will give us number of moles equal 0.6 times, I have 0.08 0.08 molarity. So the number of moles is going to be 4.8 times 10 to the power negative 6 moles. Okay, so using that value, I can calculate SO4 2 minus ions. So, but we calculated the number of moles. What are we going to do now is we are going to calculate the concentration. So I know I have added 200 milliliters of BaCl2 and 600 milliliters of K2SO4. So we can get the total volume is equal 800 milliliter, that equal 0.8 liters, correct? So from that total volume, I can calculate the barium concentration, and the number of moles I have is 8 times 10 to the power negative 3 divided by 0.8 liters, which equal 1 time 10 to the power negative 2 molar barium ions. And I can get concentration of SO4 2 minus in the same way, which equal number of moles is 4.8 times 10 to the power negative 2 divided by volume is 0.8. That should equal 6.0 times 10 to the power negative 2 molar SO4 2 minus ions. Correct? And now what I will do, I will just substitute in the Qsp because Ksp expression is that. Qsp expression is also going to be the same. Only thing is I am using the concentration which is not at equilibrium. So barium ion concentration I got 1 times 10 to the power negative 2. And sulfate ion concentration I have 6 times 10 to the power negative 2, that equals 6 times 10 to the power negative 4. And the Ksp is 1.1 times 10 to the power negative 10. So what is happening here is the Ksp is 10 to the power negative 10, that is less than 6.10 to the power negative 4. So a precipitate forms. All right, little lengthy because we had to first convert it into moles and then convert it into molarity and then substitute in the Qsp expression.